Now we're going to look at triangles under constraints when we focus on the angles. There'll still be side lengths that we're talking about, but we're going to focus on the angles, not just side lengths like we did last week. So, this was the example that we talked about yesterday when we constructed the triangle. So we already know what this triangle will look like as far as what we discussed yesterday. And so we talked about how to draw it with the protractor and all that kind of stuff. That's not really my focus today. And we already discussed yesterday that the missing angle was 70 because we have to make sure all three angles added up for a triangle equal 180. So we did that all yesterday. So now what we're going to talk about, first off, I just want to keep this fresh in our mind. What type of triangle is this? Well, all of these angles are less than 90, so it means it's an acute triangle. And obviously this is not drawn to scale, this is just to show you what we need to look at. So the main takeaway that we're going to talk about today is whether or not when we create these triangles, if they are unique, meaning that this is the only way to make the triangle, whether they're non-unique, meaning that the something about the triangle could change, and I'll show you what I mean by that later, and then we had already talked about before if it would make no triangle at all. Okay, so we're not really focusing on the no triangle at all. We already discussed that with the side lengths. We're going to focus on, is it a unique triangle or a non-unique triangle? Okay, so this one, I'm going to go back to with the constraints they gave us, talked about giving us two angle measurements and then a side length measurement. Okay, so when I think about this triangle, I have to have a 2-inch line and I have to have a 30 and 80 degree angles. Okay, well, this triangle is going to be a unique triangle, meaning that this is the only way you can make this triangle. Now, that doesn't mean I couldn't, like, for example, and everything's not going to flip, but I could, flip it around and have the 30-degree angle here, 80 here. But because I have to have both of those, they are still going to create this 70-degree angle here. I know I moved it, but that's going to have to be there no matter what. So even though I flipped it, those same numbers were having to be there, and it didn't change the side length of anything else. It didn't change this final angle. All of it stayed the same. Okay, and yeah, I could even rotate it around, like maybe the 2 inches started up here, right, instead of being on the bottom, or maybe it was on the side, right? I could rotate that around, but again, it's still going to have these same side lengths and angles. So that's what creates a unique triangle, meaning this is the only way to make that triangle. Rotating it doesn't change the makeup of the triangle, okay? So the two angles and the length of the included side determine that point in which the sides meet. And so that's what makes it a unique triangle. So let's look at one more, okay? So let's look at, we've got two angles again, and we have a side length of 1 inch now. So I'm just gonna draw it for you, or have it made already. So when we did that, I had a 1 inch line here. We had 50 on one side, 55 on the other. I could have flip-flopped those, but again, that would just be doing this. Give me one moment. There we go. That would just be doing this, and I know the numbers got backwards, but that would just be flip-flopping it. It's not going to change the makeup of this triangle. And again, I could even rotate it around and have the line going up here, but if you see, it didn't change anything about the triangle. Okay, and this is an acute triangle, right? They're all less than 90 degrees. So again, this is a unique triangle, very similar to the last one, because it had two angle measurements we had to include and a side length measurement. And so that made it so that this final angle was going to have to meet there no matter what. Even if I extended the lines, right, they're going to end up meeting at that specific angle. So these two kinds, so when you're given two angle measures and a length that's included, it's always going to create a unique triangle. So when you have two angles and one length, going to create a unique triangle because you have to include those, and so it's going to force that last angle to meet up at a specific spot. Okay, let's look at one more example for like this. So this time they're giving us one included angle, two side lengths. So to make that, first off, this ended up being an obtuse triangle this time because 120 is more than 90. But when I think about these, right, I have to have a length of 6 and 3, and I have to create a 120-degree angle. So I, again, can only make this one way. Again, you can rotate it, you can flip-flop it, but it's only going to be made this one way because I have to have these measurements and that 120 degrees, right? Like if I were to make the 120 degrees over here, that'd be fine, but I'm not going to have a longer line than that 3 centimeters because it will, like that angle is going to pull it out, right? Like if I flip it around, it's going to, oops, sorry about that. It's going to still have to have that measurement, right? Like I can't just all of a sudden make this longer because then I'm not going to have that 3 centimeter side or 6 centimeter side. So this is again a unique triangle because of those constraints given. Now this one was a little different because it gave us 2 sides and 1 angle, but still following that same idea as the other 2 examples. So let's look at one more. So now they're giving us all angle constraints, no side constraints. So if you look, I've got a 90 degree here, we got 60 here, 30 here. So this is a right triangle because we have a 90 degree angle. But then this one is a non-unique triangle, meaning that you can make this however you want as far as bigger or smaller, right? So if I were to do it like that, I know it's getting small, but you can see that it has a 90 degree, 60 degree, 30 degrees still, and I can make it bigger, 90 degrees, 60 degrees, 30 degrees. Now that did change something. It wasn't like I was rotating. I'm making it bigger or smaller. Those angles are staying the same, but the side lengths are changing. And so that is a non-unique triangle, meaning you can make this triangle multiple ways because you can have multiple side lengths, because you can make it bigger or smaller and still include the angles that they asked you to include. Okay, so I know that was a lot of information, but I hope that helped you understand how you can create either a unique triangle or a non-unique triangle.